In this video, I will discuss and I will tell you more about the disturbance signal. I received this message from one of the user in the YouTube. How did you implement the disturbance in Centum VP? So I will explain this disturbance topic in general, and I try to answer this question. So I created some slides here. It's a very simple classic temperature control in a reactor. It's a real industrial application. We have the heat exchanger for steam or steam applied directly to the mixture of inlet, and we have the condensate outlet and the product outlet. We have this mixer, the temperature transmitter, and this PID controller. This TIC is controlling the temperature, the total temperature of liquid inside or the product inside the reactor. As you can see, it's a very simple process design, and it's possible to transfer this process structure into control block diagram. This is the control block diagram, and this part is related to the disturbance. Disturbance can be considered as the temperature variation in input, possibly if it's water or other product. We pump the water from the other tanks, or we pump it from the other plants, and the temperature, for sure there are some temperature differences in the inlet water or inlet liquid, and this temperature difference will change the overall temperature in the reactor. In most of the cases, we can consider a random curve, something like a pulse change or random signal. We can use this random signal to simulate the disturbance signal, or it's possible to use some step changes in order to simulate this the disturbance. We normally use the same scenario here, a different type of control system. If we want to simulate the disturbance, normally the disturbance is added or subtracted from the process value. This is the process value, and we need to show those waveforms, those variation, and we normally have a disturbance signal. Normally we generate the disturbance signal separately. In most of the cases, it's possible to fit this random signal or this waveform in to a first order Laplace filter, first order filter, and after the output of the filter can be added to the process value here. So depends on the scenario and the mass balance. We need to consult with the process engineers. If we want to have an exact model, we need to know more about the dynamics in the reactor. If we know more about the reactions, we will provide a better model. In some cases, possibly the variation, flow variation of the product, flow variation, temperature variation, many other scenarios may involve in the disturbance calculation, but for the easiest way of generation, you can generate signals, repeated signals or periodic signals. In Centum VP, I used Sybil programming language in order to generate those periodic signals, and you can simply add to any other variables to form the process value. In the examples related to Centum VP course, we use the first order filters or second order filters to make example more realistic. We consulted with the process engineers, and we made the models as actual or very similar to the real industrial cases. And the control structure is very simple. You can see that we have the set value, PID controller, valve, process model, disturbance, and the sensor. So if you have any question regarding to the our videos in YouTube, our training courses on our website, please share your thoughts in the comment section. We will do our best to answer your questions. You can use the communication passage in our website if you have any question regarding how to enroll to those courses. Thank you for watching this video.